So usually what I've been doing is I've been writing down a summary with you, but because we have sort of a limited amount of time, I've kind of already written down a summary of everything that you need to know, and we're just going to kind of quickly go through it. You can take screenshots, and then we're going to get into our questions. Okay, so in terms of the equations, in terms of what you need to know, we have broken down before the types of questions that you're going to get, and a little bit later, I am going to talk again about the types of questions that you can get or you can expect in these two sections. But in terms of equations, there are a couple different types of equations you need to be able to solve. So quadratic, inequalities, surd equations, and simultaneous equations. Actually, I'm not forgetting anything. And exponential sort of situations, but we'll deal with the exponents in a second because it's a bit tangential. So in terms of your quadratic equations, the most important thing to remember is that you need to make one side equal to 0. You have to get it into standard form in order to be able to solve that equation. If it's not in standard form, you're not going to be able to solve the equation. So this is standard form. What you'll see as we go through some examples, there is often a mark allocated to standard form, making it equal to 0. So please remember to do that. Quadratic equations rely on your ability to factorize, but please remember grade 11s. You're not grade 11s. I feel like I said this a lot to my grade 11s today, so it's in my head. Please remember grade 12s. That you have got the formula. Okay, so when in doubt, if you are so stuck in terms of factorizing your quadratic equation, just use the formula. Okay, the formula will always give you the answer as long as you can substitute in values. It will always give you the answer that you need. All right, so if in doubt, use the formula. That is tried and tested, it will work. Right, with quadratics, we also then need to remember our nature of roots. Now, nature of roots is sometimes asked in question 1, but oftentimes it is more asked with functions, and we have already spoken about this, but I'm just giving you a little reminder of your discriminant, what it means, how we can then work with it. So nature of roots is looking at what type of intercepts, what type of roots do you have for a quadratic function. Now, this little sort of family tree diagram, family tree is not the right word, tree diagram gives a summary of your roots. Now, remember the discriminant, so delta b squared minus 4ac, is the part underneath the square root. So actually, let's do it like this. If you look at your quadratic formula and you look at your discriminant, this bit underneath your square root here is the discriminant that you then work with. And depending on the value that has been square rooted, we can tell different things about the roots. Obviously, if that value is negative, you're square rooting a negative number, so that's where we get non-real roots. If we're talking about a value that is real, we then get real roots, and we can split it then according to more specific types of roots. Right, so that's just a summary of sort of your nature of roots. Like I say, it can come up in this question, but it more often comes up in questions 5, 6, 7, where you are talking about your functions. But just sort of at the back of your mind, bear that in mind, because it can come up every now and then. Right, in terms of then inequalities, so inequalities are still types of equations, except for the fact that now instead of a singular value, we are getting a range of values. Inequalities, at this level, you need to be dealing with quadratic inequalities. You essentially determine your critical values through solving your quadratic equation. So make one side equal 0, factorize, etc., etc. And then you need to use a graph. Some people use like a number line. That's absolutely fine. But you cannot, unless you like have a very, very good understanding of your quadratic function, you cannot go straight from your critical values to an answer. Okay? We need to understand that when we are being given different types of inequalities, we are looking at different parts of our graph. So for example, when I'm telling you that f of x is greater than 0, we're talking about the arms above the x-axis. If we are talking about a situation where your expression is equal to 0, we are talking about our roots, our two x-intercepts that we have. When we are talking about a situation where our inequality or our expression is less than 0, we are talking about this part underneath your x-axis. So it is really, really important that we do remember to solve this as we would, but understand that we are using a graphical representation to understand where the inequality exists. Right, we then have surd equations. Surd equations are very easy equations if we remember how to solve them correctly. Sorry, harder. The most important thing here, guys, is when you solve a surd equation, the first thing you need to do is isolate the surd and then square both sides. You are not squaring individual terms, you are squaring both sides. The reason for that is if we have a look at like a very basic example. So if, let's say, for example, we had, I don't know why my brain's having a brain fart right now. Okay, my brain's having a bit of a brain fart. I'll come back to this example. Don't know why it's having brain fart. Shame. It's having a bit of a time right now. Anyways, you have to square both sides. You're not squaring individual terms. Also importantly with your surd equations is that you will get two answers. Because you are squaring both sides, you are invariably going to end up with an x squared, which means quadratic equation, which means two solutions. And what we need to bear in mind is that the original surd equation was not quadratic. So we're actually solving for a singular x value. So you have to remember to eliminate one of your solutions. If you haven't eliminated your solutions, you are going to lose a mark because once again, there are marks allocated for you understanding that only one of those solutions is valid. Right, then we have simultaneous equations. Simultaneous equations, again, at a grade 12 level, you're going to get one quadratic equation and one linear equation. Generally, what's going to happen is you're going to isolate a variable from your linear equation, substitute that into your quadratic equation, and from there, you will then get your solutions. Right, obviously, for whatever reason, I just didn't finish my sentence there. So just a reminder for you, you need to remember that you are solving for two variables. So what often happens for whatever reason, we start to solve our equation and we're doing really nicely, but then all of a sudden we just forget the fact that we've got two variables we're solving for. We are solving for x and y. So often what will happen is we maybe solve for x already, and then we just don't substitute back and solve for y. Now, it's only 1 mark of the 5 or 6 marks that your simultaneous equation is worth, but it's a really silly mark to lose, okay? That's 1 mark might be a difference between a pass and a fail, an A and a B. Don't forget, right? So you're solving for 2 unknowns in a simultaneous equation. Please make sure you do actually get solutions for both variables. Right, I'm just going to start up here in case anyone wants to screenshot all of that, and then I'll carry on with our little summary. Rato?
Hi, ma'am.
Hi.
Ma'am, do you mind just adding by the inequalities how you would, okay, let me try and structure this question. So basically, how the parabola, ma'am, how, now I'm trying to find out. So, ma'am, you know how usually you'd have to write the inequality as like one rung inequality or separate the two? So, do you mind just adding like
when you have 1, when you would have 2?
Yes, ma'am.
Okay. So you would have 2 when you're looking at the arms, okay? Because the arms are disjointed. So, oh gosh, let's do it like this. So this situation where it's greater than, you will have 2 solutions. And the reason for that is because you can see that where it's greater than 0, it's the 2 arms of the parabola, but those are not continuous. They don't kind of join with each other in the section where it's greater than 0. Whereas the less than 0 situation, so the bottom one, this is where we get one solution with x in the middle. So what I mean by that is if, say, for example, we are going to do examples, so don't stress. If, for example, your critical values were -1 and 3, and we're looking for less than, okay, so we're looking for less than 0. What we are looking for is this bum bit of my parabola, and so that would now be with x in the middle and my inequality on either side. So this situation over here where it's less than 0, that is one continuous sort of section of my parabola. So it'll be one inequality solution. All right, we are going to have a look at some examples, but yeah, good question. So if it's greater than 2 arms, separate solutions, less than one continuous bum section, one inequality. All right, guys, and then the last little bit in terms of your equation stuff that you need to know has to deal with exponents. These questions generally are the problem-solving complex questions in question 1, so the last one. And really all it requires from you is to know your laws. Okay? If you understand your laws of exponents, the idea of rational exponents, etc., you are going to be absolutely fine when it comes to a problem-solving type of question. Like I said, 80-90% of the time, it relies on exponents, and particularly rational exponents. So rational exponents are these ones over here. These are all your laws that you need to know. These ones over here where you're dealing with surds, essentially. The exponents on the right, not on the right, on the left, these ones over here, these are all the exponential laws that you've been learning since grade 8, grade 9. So we've been working with these for an age. Whereas the rational exponents, we kind of introduce in grade 11, and we need to be comfortable with those rational exponents. All right. If we then, actually, no, let's take a screenshot of all of the equations, and then we'll get into the number patterns, and then we're going to get into our examples. All right. Rato?
Ma'am, I just have a quick question with one of the laws. It's like the second law from the rational side.
Mm-hmm.
Yes, that one, ma'am. So an example, if it were to be, I would say, the n square root of 3x, would it be 3 1 over n times x 1 over n?
Exactly, because what's happening is if you've got this 3x under your root, it's 3 times x. So you're looking for the nth root of 3 times the nth root of x, and each of those can then be written with a rational exponent.
Oh, okay, ma'am. But then if it was, for example, your 4, we can just go to the final answer, which would be 2 times 1 over n.
It would obviously depend on what the root is, but if it, let's say, was the square root of 4x, then you can say square root 4, square root x. The square root of 4 is 2, and the square root of x is x to the power half, yeah.
And then if it was n, it would be 4 1 over n times.
Yes.
Okay. Thank you, ma'am.
Sure. Alrighty, guys. If we get into the number patterns, number sequences and series, whatever you want to call it, we have got 3 types of series sequences that we work with. Okay, I've listed the first 2, arithmetic, geometric, and then quadratic. So arithmetic, there's a constant first difference. Being able to identify your patterns, very important. So a constant first difference for arithmetic. There are 2 formulas that you need to know, that for Tn, so the general term, and that for the sum of a sequence. Geometric patterns have a constant ratio. Again, 2 formulas that you need to be able to work with, primarily your Tn and your sum formula. But what we also need to remember is that with geometric series, you can get what we call converging series. Now, converging series, this idea of your R value being a fraction, positive or negative, is very, very important, very useful. The converging series basically just means is as you add more and more numbers, so as you add to an infinite number of terms, your values approach a certain number. And what happens is, if your R value is a fraction, what you're doing is you're dividing each of those terms. So for example, if we had the series 8 plus 4 plus 2 plus 1, etc., each time we are dividing by 2. So that means our R value is a half, which fits into this restriction over here. But what you can see is that we're making these values smaller and smaller. So it'll be a half, a quarter, an eighth, 16th, etc., etc. We are adding smaller and smaller and smaller and smaller increments as we go along. And so what we're going to find is that because we're adding just a teeny tiny little bit each time, we are going to start to approach a singular value. And in this case, the sum to infinity would be 16. So as we start to add all of these decimals all the way up to the infinite term, we are going to approach a specific value. And that is what a converging series is. We are working out what value it approaches as we add an infinite number of terms. Right, so that's arithmetic, geometric. These are the only two where we work with the sum. Quadratic sequences, we do not work with the sum. We just work with the sequence, so the list of numbers, rather than the addition of those terms. Because arithmetic and geometric are the only ones where we work with a sum, these are the ones where sigma can be involved. Okay, now sigma is one that for whatever reason confuses us quite a bit. There's no reason to be confused by sigma. The sigma questions are actually, once you practice them enough, incredibly easy questions, but we do consider them to be the more complex questions just because we know sigma is a bit confusing. All right, so this E symbol over here is sigma. That means sum of. And the thing with sigma is you need to be able to read it. So the number at the top is the last term that we add in the sequence. The number at the bottom is the first term that we add. And then whatever's next to sigma is your general term. So essentially, if we took a random example, let's say I had sigma of n equals 2 to 7 of 3n plus 1, for example. What this sigma expression is saying to me is, I want to add, starting from term 2 all the way up to term 7, the terms that follow this rule over here. So I'm going to be adding term 2, so 3 times 2 plus 1, term 3, term 4, all the way up to term 7. Okay, whatever. And that is essentially what I'm wanting to deal with in terms of my sigma. Now, this doesn't happen often, but as you can see in this example, I've started adding from term 2. I haven't started adding from the first term of my sequence. And so what that means is we just need to be careful then in terms of how many terms we're adding. So if we just count, I'm adding term 2, 3, 4, 5, 6, and 7. I'm actually only adding 6 terms here. And whenever, in particular, this bottom number is not 1, if we ever need to figure out the number of terms that are being added, we have this helpful little formula that allows us to determine that. That formula is your top number minus your bottom number plus 1. So we've just established this would be 6 terms that we're adding in my example. If we use our formula, top number 7 minus bottom number 2, that's 5, plus 1, gives me 6 terms that I'm adding. And we just counted that we are, in fact, adding 6 terms. Now, guys, this doesn't come up a lot. I'm just putting it out there in case it does. Sigma generally is we'll give you a sigma expression. We're asking you to then solve for the n value or something like that. Or it's kind of these two sequences have the same sum, whatever the case may be. Generally, again, not a hard question. It's understanding what sigma is saying to you. Right, then the last type of pattern that you need to be comfortable with is a quadratic pattern. This is where we have a constant second difference. So arithmetic, constant first, quadratic, constant second difference. And this is the one where you need to know these 3 formulas if you want to find Tn. So Tn is found using 3 separate formulas. We need to know them. We don't give them to you on your formula sheet. It's an expectation that you know it. But quadratic, really, nothing major. There's no sum that I can ask you because there's no formula, essentially, that we use here. But obviously, it can be. There is an equation somewhere out there. It's just not something that we learn as part of our syllabus. Right, if you want to screenshot that, you can do so. So like I say, 3 types of patterns. We need to be able to use their formulas. We need to be able to apply it. The tricky question is generally the sigma question, just because we often struggle to understand what sigma is saying to us, but realistically, not that bad. We just got to practice these questions. Right, then in terms of what you can expect for these two sections, so for the algebra, there are different types of questions that we're going to ask you, and generally it's set up in this order pretty much. So you'll get a quadratic equation that generally you can factorize for like 2 marks. You'll get a quadratic equation where you have to use a formula. The giveaway here will be, they will say to rounding your answer to 2 decimal places or leaving your answer in third form. That's a giveaway that you should use a formula. But obviously, you should always use a formula if you aren't sure. You then get a quadratic inequality, a surd equation, a simultaneous equation, and a complex question that, like I've already said, generally involves exponents. Your sequences and series question is generally going to be a question that's just a quadratic series sequence by itself, an arithmetic sequence as well as an arithmetic series. Sometimes they're a combined question, sometimes they're separate. Geometric sequence as well as a geometric series. Again, sometimes combined, sometimes separate. A sum to infinity question often comes up, so a converging series question, as well as a sigma notation. And like I say, sigma notation often is the more complex question that we generally get. All right, so that is what you can expect. It's pretty much exactly what I've said we need to know in terms of our summary, but those are the questions that you can expect in this these first few questions. So generally algebra is the first question, sequences and series are then generally questions 2 and 3, and then your functions start 4, 5, 6, etc., etc. All right, I'll just wait here for a screenshot. Obviously, guys, if you have questions you ask, I'm just going to go. But let's get into some examples. Okay, I would like to be able to do examples of both, so that'd be great. But let's see how we go. Okay. So much like as always, you're going to do some by yourselves, you're going to do some with me. We'll go from there. So the first question says you are given f of x equals x plus 4 times 3 minus x, and g of x equals x squared minus 49. I chose this question specifically because all of the questions you're about to be asked in 1.1 are straightforward, easy questions. But the way they presented the information to you is a little bit different, right? And because it's a little bit different, often when we see it, we panic and we think we can't do it, but you can. Okay, there's nothing overcomplicated here. So 1.1.1 says solve for x if g of x is equal to 0. All you need to do, guys, is take g of x and make it equal to 0. It's like solving for x-intercepts on a function. So this is a 2 marker. I'm going to give you 2 minutes. I want, what are your solutions for x if g of x is equal to 0? And remember, guys, g of x is x squared minus 49. So that's quadratic. We do need to essentially follow those steps for a quadratic solution. Ella, I'm not too sure where we got to.
Oh, no, sorry, ma'am. I mixed it up. Sorry. I only realized afterwards
no,
that I made a mistake.
no, that's absolutely fine. Right, guys, just so you're aware, when I say 2 minutes, I'm using the mark allocation. So we've had this conversation before where I've said use your mark allocation as a time management strategy. I'm helping you manage your time. You might not feel like it and you might feel like I'm rushing you, but a question that is worth 2 marks shouldn't take you longer than 2 minutes to complete. So that's why when I say 2 minutes, it's that you can get an idea of how long these questions should be taking you. Right, you've got like 30 seconds left. Okay. So this one, very straightforward. You could actually just go straight to the answer. Now, you've got two options of how you want to solve this. Personally, I prefer to factorize. So the solution on the left, that's what I prefer. The reason I prefer that, and I've said this to you guys before, is because often we forget the plus or minus when we use the square root method. I don't have a problem with the square root method, but don't forget to square root, okay? Or rather, don't forget that when you square root, you can get a positive or a negative solution. But essentially, mark for factorizing, mark for your answers. Right, if we look at 112, excuse me, it's asking us where f of x is greater than 0. So f of x's expression is the x plus 4 times 3 minus x. And what we need to realize here is that we have essentially a quadratic inequality. Now, guys, there's a few different ways that you can deal with the situation. If you would prefer to factorize it out, that makes no sense. If you would prefer to distribute it out, sort out any negatives, and then refactorize, that's absolutely fine. But remember, these two brackets imply that it is already factorized. The problem that I'm facing, though, with this particular situation is the fact that this bracket over here makes it a little bit tricky for me to find my critical values. So what I'm going to do is, we know to get this bracket in the order of x plus or minus a value, we can essentially times that factor by -1. By times it by -1, well, I'll say that factor, this term by -1, we now have a negative in front of my bracket, so x plus 4, but now my bracket order switches. We should remember this whole switching in the order when times it by a negative from grade 10, when we learned about when you have a highest common factor, but the brackets are in a different order, we can times the term by -1 and we can get it in the order that we want it. Right, so now this makes it a lot easier for me to find my critical values, but obviously now the problem is I have a negative in front of my brackets. Now we know that when it comes to inequalities, if I want to get rid of, so divide by a negative, all that happens is I swap my sign. So instead of it now being greater than 0, it's now going to be less than 0. That's all that happens when I divide away a negative. So my critical values here are now x equals -4 and x equals 3. You get your critical values by actually making these two brackets equal to 0, so solving like you would a normal quadratic. And this is now where the graphical representation comes into play. Now, the two x-intercepts are your two critical values, so -4 and 3. And we are looking specifically where that expression is less than 0. So less than 0 is the whole sort of bum of my parabola. Because it's one continuous section, I'm going to have one solution with x smack bang in the middle. And I've solved my quadratic inequality. All right, so this one, a little bit trickier, absolutely, because of the fact that you had to multiply by the negative. It does make things a little bit harder. But remember, we always want our standard form, for lack of a better description, to have that positive x squared coefficient. So I could divide away the negative, just swap the sign, and you're able to get your answer. All right. In terms of a mark, marks, allocation. A method mark, particularly for that times by a -1. You then get a mark for your critical values, and then a mark for your inequality. Now remember, generally that inequality mark is an all or nothing mark. So I don't know, if for example, maybe you'd add in an equal sign accidentally, you don't get that mark. If you'd accidentally written the inequality as two separate inequalities, even though your critical value is right, you don't get that mark. So just remember to be really careful, and this is why the graphical representation is so helpful and so important. Right, 113 says f of x equals 5 rounded to 3 decimal places. Again, we know what f of x is. We're going to make it equal to 5, and then we're going to have to solve. So this is a 4 marker. I'm going to give you 4 minutes. Let's give this one a try. I'll give you a hint. You do need to distribute, and remember standard form. And again, grade 12, if at any point you have questions, you just need to ask. You can put answers in on the chat. That's all absolutely fine. But I am kind of just going. I'm expecting you to ask questions if you have them.
Ma'am, on 1.1.2, why did we divide by -1?
Okay, so remember, we always want the sign in front of my bracket, so essentially the A, to be positive. So that's why we want to get rid of that negative, because we don't actually want the negative there. So we'll divide both sides by -1 so that it becomes positive.
Okay.
Yeah. So perhaps importantly to say, it's not necessarily that you have to divide it by -12. You can work with it if you by -12. What? You could work with it as a negative, but then you need to bear in mind you're dealing with a sad parabola and you're then dealing with where is it greater than. So you're now dealing with the top part. It will give you exactly the same solution. So I'm not saying it's wrong, but our minds generally work with a positive quadratic. So it is easier to make it positive. Obviously, again, if you have a really good understanding of these things, it's cool for you not to. But it does just make your life easier just because that's generally what we're more used to. Right, 2 more minutes for 113. Alrighty, let's have a look. Again, if you're not done, it's not the end of the world. Just bear in mind that that is 4 minutes. We should be able to finish that question in 4 minutes. All right, so I did give you 2 hints. I said you would have to distribute and you will have to get your standard form. Anytime we have a quadratic equation that is not equal to 0, but part of it is factorized, unfortunately, we have to distribute everything and we have to refactorize to take into account whatever the constant is that it's equal to. So yes, we did have to redistribute, which is what I'm doing over here. So this is the distribution of my binomial times my binomial. You then want to obviously bring that constant so that it's part of your standard form. Once you have that, you can refactorize and you can get your solution. Now, guys, just bear in mind, obviously, because it said 3 decimal places, it gives away that you're going to have to use the formula. But just as a sort of note, if, for example, you're going to factorize an expression using the formula, I always have to see the substitution into the formula. I don't need you to rewrite the formula, but I do need to see the substitution into the formula. So there are your 4 marks. You can see it. SF, standard form, substituting into the formula. I have to see that. And then your 2 answers. This is also the question where we would penalize you for rounding. Okay, somewhere in your paper you will be penalized for rounding, for notation, all of that fun stuff. This is the point where you would have 1 subtracted if your rounding off was incorrect. And so again, don't make a silly mistake with your rounding because you are going to lose a mark. Right, let's take a screenshot of those first 3 while you're doing that, Lorato.
Ma'am, so for this question, so for 1.1.2, I already distributed the whole bracket and everything, and it gave me a quadratic. So what I did was I took the quadratic formula that I got there and just made it equal to 5 after making. Fine. So then, but basically, since you don't get a mark for it, is it okay that I did that?
Oh, yeah, absolutely. Even if you did get a mark for it, it's fine because your mark. So generally, what happens not generally, what happens in your finals is your marker will mark an entire question. So one person will mark your entire question 1. So they will be able to see that you've already done the working out previously and where you got your quadratic from. So it's absolutely fine.
Oh, okay. Thank you, ma'am.
Sure. Okay. Right. 1.2.1. This is a surd equation. So remember, surd equations isolate the surd, which in this case is already done. It's already isolated on the left-hand side. And then your second step is to square both sides. So again, 4 marks, 4 minutes. I want you to solve for x. And remember, you have to eliminate one of your answers. Lilo, is it wrong if... I'm assuming you're talking about the last one. Absolutely not. I divided by -1 as well. So from this step to this step, that is me dividing all of my terms by -1 to once again make a positive. So that's absolutely fine. Kelebogile?
So, ma'am, when dividing with a -1, the sign changes.
Yes, exactly. Well done.
Okay.
Good. So guys, that's a key thing. Whenever you divide by a -1, whenever you divide all times by negative, the signs are going to change. But the key thing is multiplying or dividing by a -1 doesn't change the number, but it does change the sign, exactly as Kelebogile just said. Okay, so 121. Leila?
Hi, ma'am. Sorry, you're breaking up on my side. Can you please explain the rounding off thing again?
Can't really remember what I said. The only thing I can remember I said is that this question with the use of the quadratic formula and where you have been told to round. So because the question specifically said round to 3 decimal places, it will be the point in your test or your exam where we will penalize you for rounding. So if you'd rounded off incorrectly, you would lose a mark here.
Okay, thank you so much, ma'am.
Sure. I think that's what I said. Right, we've got 3 more minutes. Remember, guys, surd equations, this is the one where we do need to remember to eliminate one of our answers because it can only be one of them. Nice, grade 12, well done. I'm liking the answers I'm seeing. Mshatsi? Mshatsi, have you got a question?
Hello, ma'am.
Hi.
Ma'am, how do we comment our answers like on the group? I'm new. I came last week, so I don't know how.
No. That's okay. There should be like a little speech bubble at the bottom of your screen. And if you click on that little speech bubble, it'll open the chat and then you can type your answer in there.
I don't have a speech bubble.
Okay, maybe someone can correct me. Do you see a speech bubble when you guys do this? Hang on. Okay. So this is going to be wild because you're now going to have my face twice. Oh, you've got my face so many times because it's mirrored. But here at the bottom, this little speech bubble over there, if you click on it, it opens the chat for everyone.
Oh, okay, ma'am. Thank you.
Did you find it?
No, I'll just look for it. Like I leave the meeting or like what?
That's so bizarre. There definitely should be something with like a little speech bubble or a little like kind of like WhatsApp looking thing. Are you using your phone?
Yes.
Okay, Lorato, yes. Yeah, I know on the phone that it looks a little bit different, but now I can't remember what it looks like on the phone.
Oh, it says in-call messages.
Oh, there we go.
Oh, okay. Thanks.
Found it.
Thank you.
Awesome.
Ma'am.
Thank you. You said like this is me constantly. I never know what's happening in life. Okay, great. Okay, thanks everyone for your help. Appreciate you. Okay, let's have a look. Nice. Right, so you did get 6 minutes there, but obviously that was because of my confusion. So the surd is already isolated. We square both sides. Once we've squared both sides, we have a quadratic equation. Okay, so remember the quadratic equation, you do need to solve it through factorization and all of that fun stuff. But really important, you have to remember to eliminate one of your answers. You have to. If you haven't drawn a line through and you've left it as x equals 7, x equals 2, you are going to lose a mark. We have to see that you have eliminated one of them. So that's why the mark here is for only 7. You can just leave off that answer entirely and just not write it down at all. That's absolutely fine as well. But you either need to put a line through the equal sign or leave it off entirely so that we know that you know it is only one of those solutions. The way you check which solution, you basically just need to substitute back into the original equation and make sure the left-hand side equals the right-hand side. So for example, when you substitute in 2 into your equation, you would have the square root of 2 plus 2 equals 2 minus 4. The square root of 2 plus 2 is the square root of 4. 2 minus 4 is negative 2. That's not possible. We know that. You can't square root a value and get a negative. Hence, why that's the solution we cross out. Okay, we have to eliminate which one it isn't. Right, 1, 2, 2. I was going to do with you just because A, it's not really a question we ask in finals, but B, if we did ask it, I think many of us would struggle. Okay, now the reason why I'm saying that is because this is a rational exponent situation, and often we just forget how to deal with rational exponents. Okay, so in terms of dealing, there's a couple different ways that you can deal with a rational exponent. It's kind of your choice how you choose to deal with it. Some people do not overcomplicate it, but do kind of overcomplicate it for sake of understanding what the question is asking them. All right, so we've got 2x to the power negative 5 over 3 equals 64. The first thing, guys, get rid of this 2 in front, right? That just makes my life a whole lot harder. Get rid of it. So x to the power negative 5 over 3 is equal to 32. From this point, we have some options. So option 1, I've just zoomed my entire screen in unnecessarily. I don't know where I'm at. Okay, sorry. I don't know what I'm doing. You can just ignore me, right? So option 1 is you can just use the reciprocal, right? So what does it mean when I say reciprocal is, remember the goal is to get rid of the exponent so that I just have x. Now, if I raise this whole thing to negative 3 over 5, so I flip the fraction, the negatives cancel, the 3 in the denominator cancels with the 3 in the numerator, and the 5 in the numerator cancels with the 5 in the denominator. I've not gotten rid of the exponent. I just have x left. But we know what we do to the left, we must do to the right. So this would now give me x is equal to 32 to the power negative 3 over 5. And then you just type that into your calculator and you get your answer. It's not like you have to now go convert to surds or anything like that. You type it into a calculator and you have your answer. And that gives you 1 over 8. Right, but some of us do forget about that whole reciprocal situation. And so many of us do try and convert to a surd. Now, once again, I'm not saying that this is wrong, but you are making it more complicated for yourself. So what many people want to do is take this rational exponent and make it surd. So remember, the denominator is the root, so it is the cube root of x to the negative 5, which equals 32. We want to get rid of the cube root, so we will cube both sides. That gets rid of my cube root. Now remember, x to the negative 5 is 1 over x. Actually, no, let's not even. No, we are going to do that, sorry. Equals whatever the 32 cubed is. And now we have to still solve for x. Because it's in the denominator, we have to times both sides by x to the power 5. And then to get x to the power 5 by itself, I would divide by 32 cubed on both sides. And so x to the power 5 is equal to 1 over 32 cubed. And then I still need to get rid of the exponent of 5. So I'm going to fifth root both sides. And whatever the fifth root of 1 over 32 cubed is x. Do you see how that's confusing? Okay, that's a lot of nonsense for nothing. Right? So you're welcome to go and convert and then do your inverse operations. There's absolutely nothing wrong with that. Absolutely nothing wrong. But it does mean a lot more complex situation going on. Right, my advice, use the reciprocal. So Kani's just asked for an explanation of the reciprocal again, and this is a good point, and I'll kind of link what we've done. So Kani, what I'm saying is we know that once we've got divided by the 2, the only thing left I have to get rid of is the negative 5 over 3. I want to get rid of the exponent so that I just have x. Now, if we have negative 5 over 3, and I times that by negative 3 over 5, the 3's cancel, the 5's cancel, the negatives cancel, and so actually all I'm left with is an exponent of 1. So that's why we can use the reciprocal of the rational exponent and raise it to 2, so multiply those two exponents together, because it gets rid of everything. But if you have a look, okay, we can see that if we take just that x to the power negative 5 over 3, we are working with the cube root and to the power 5. If you look at this whole beautiful mess on the right-hand side here, the opposite of cube rooting is cubing. The opposite of raising to the power 5 is fifth rooting. This exponent of negative 3 over 5 deals with the fifth root and the cube of something. If you have a look, those are the exact reciprocals of what we're trying to deal with. So this to the power 3, obviously now that makes no sense here. You can't see anything. So this to the power 3 is the inverse of cube rooting. So that's cancelling out the cube root. This fifth root is the inverse of raising to the power 5, cancelling out the power of 5. And so the reciprocal essentially does all of my inverse operations in one shot. I don't have to write it out. I don't need to do anything. I just do it all in one shot. Okay, now guys, again, this is not a question we typically ask, right, at all. But it could pop up. We never know. So let's make sure we can deal with it. So you're going to get a mark for your division by 2 to getting rid of your coefficient, a mark for applying your exponent law appropriately, and a mark for your answer. It is only 3 marks, so not a lot. But just remember when you're raising to a rational exponent, so a fraction, just multiply by the reciprocal because it does all of the inverse operations that I'm trying to do over here in one go. Okay, so Kanye, I hope that makes sense. Just let me know if not. Lorato?
Ma'am, do we have to, for the way you did it, like the second way with like the roots and stuff, do we have to write the value of 32 cubed, or can we just keep it to 32 cubed?
Just keep it as 32 cubed. You'll eventually type it all into your calculator. So yeah, 32 cubed is going to be something stupidly big, so just leave it as 32 cubed.
Okay, thank you, ma'am.
Sure. Kanye?
Ma'am, it's the signs that are confusing me. So on the left-hand side, in the first step, it's positive 3 over 5. And then on the right-hand side, it's to the power of a negative 3 over 5. So I don't understand like the sign part.
They are both negative. So this is a negative and this is a negative.
Oh, okay.
Sorry. Yeah. No, it's because I canceled the negative out. Sorry. I was trying to say that that negative will cancel with the negative there. My apologies.
Oh, okay, ma'am.
Okay. Sorry, guys. Yeah. So I'm saying raise it to the negative as well so you can get rid of the negative sign. My bad. Right. Let's take a screenshot. Oh, sorry, Leila.
Hi, ma'am. Ma'am, I just wanted to ask the really long thing, the long method that you did on the other side. Does it like affect your mark allocation at all? Is it just like a really long
You're
way of
still
getting to the
only going to
answer?
get, you're still only going to get 3 marks, but it just means that, so your 3 marks will likely then be for probably still dividing by 2, 1 mark for all of those inverse operations and 1 mark for the answer. So it just becomes a lot
thank you,
stingier.
ma'am.
Pleasure.
Yeah, it looks like it.
Yeah. Kanye, is your hand still up? Or rather, do you have another question?
No, ma'am, it's fine.
Okay, cool. Alrighty, so I hope we've screenshotted. Right, so this is your simultaneous question. This is pretty stock standard. All I've done here with the 1 and 2 is I've just numbered my equations. I like to do that. You don't have to. You can ignore the 1 and the 2. So let's maybe just do that if you don't want it. I want you to solve simultaneously. 6 marks, 6 minutes. Starting now, let's go. Obviously, if you have questions as you go along, just ask. But we're solving simultaneously, and I did tell you how to do that earlier, so let's see. I definitely am getting some different answers. I'm wondering now if I've done something stupid. So I'm just going to double check myself real quick. But do continue just because all of you are getting something similar. So. Okay, let's check. Because I'm not getting a y equals 2. So let's just double check. You can either tell me where I've gone wrong or you can see where you've gone wrong. But let's just see. Right, so from the first equation, that linear equation, I isolated x. So I got x alone, which means 2y is equal to negative. No, it doesn't. It means x is equal to 2y minus 1. I brought that negative 2y over. I then substitute that in place of x in my second equation. So 2y minus 1 squared minus 7 minus y squared equals negative y. I said 2 instead of negative 2. But it is 2y. So guys, just remember, this 2y, when you now bring it over, it becomes positive 2y. So that's why positive 2y. Then I expand out that bracket. So 2y minus 1 times 2y minus 1. That gives me this trinomial over here. Then the minus 7 minus y squared equals negative y. Simplify everything. So essentially standard form. I get 3y squared minus 3y minus 6 equals 0. I can divide everything by 3. So I do. And I get y squared minus y minus 2 equals 0. Factorize that and I get my solutions. Okay, so just double check for me. Let's make sure we are all on the same page. I'm just going to fill in the mark allocations while you're checking where either you've gone wrong or I've gone wrong, and you can just let me know. Okay, cool. 1, 2, 3, 4, 5, 6. Okay, so hopefully we can see where maybe we made a little mistake. It was probably, guys, honestly, with these questions, because there's so much simplification, it's generally speaking a sign where we go wrong or we miss out a term somewhere. It's not for lack of understanding what to do. It's just a slip. Okay. Just remember again, you are looking for x and y. So please remember to sub back to get that final mark. Obviously, it is just 1 mark, but we don't want to lose 1 mark unnecessarily. All right, let's screenshot. If we have any questions, you can ask. Okay, so Kanye, no, sorry, I don't know what I was saying. You can just ignore my words. Not there. Right, it seems like perhaps the mistake was making it negative 2y right at the start rather than positive 2y, but hopefully we've seen what happened. Lorato?
Ma'am, my mistake was y. I said y minus 1 and y plus 2 instead of y minus 2 and y plus 1 equals to 0.
Oh, okay, so you swapped your signs in your factorization.
Yes, ma'am.
Okay. Okay, so that also could just be one of the things. And again, guys, it's not because you don't know what you're doing. It was just a slip. Okay. So then you'd lose the mark for the y values, but you could get a CA mark for the x values. So you would only lose 1 mark. Okay, good. Right, I hope we've all got our screenshots. So guys, that's basically the bulk of algebra. Okay. There will generally be a problem-solving question, but because time is a slipping away, I do want to at least do some sequences and series. So I'm going to jump to that. But as you can see, this is already We've done 2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 of the approximately 25 marks of algebra. That is the bulk of algebra. Okay, your problem solving question is generally 3 to 5 marks at most. Alrighty, so I'm going to jump to the sequences and series. Obviously, guys, you have got access. Oh, that is what I wanted to say. I keep saying, oh, I'll put the links up onto Google Classroom for past paper. They're there. Okay, I went and double checked. The past paper links are on the Bootcamp Classroom. You might need to scroll down a bit, but they are all there. All right, so you have got links to all your past paper sites there for you. Alrighty, so as I said, one of the types of questions you can expect in sequence and series is just dealing with the quadratic. So 2.1, because that's a number. 2.1 says, given a quadratic number pattern, negative 120, negative 99, negative 80, negative 63. 2.11 says, write down the next two terms of the pattern. And 2.12 says, determine the nth term of the number pattern in the form Tn is equal to an squared plus bn plus c. Right, so remember, quadratic number pattern, constant second difference. That's not how you spell constant, is it? Constant. And so that is sort of what you need to have in your head as you go along and answer this question. So I'm going to give you 6 minutes to answer those 6 marks, the next 2 terms, and the nth term of the pattern. And then we'll go from there. But let's give this one a try, please. Three more minutes. With Latzi, nice. All right, nice, go tells. Let's have a look. So the next two terms should have been relatively straightforward, negative 48 and 35. And then hopefully what we saw is that our constant second difference was a subtraction of 2. So you can see there in the green, I've sort of figured out what my differences are. And I would advise you do this. You can do it roughly in pencil, just so you know what you're working with. Right, then we have to use those three equations that I gave you earlier. The 2a equals your second difference. 3a plus b equals your first difference. And a plus b plus c equals your first term of your sequence. Solving for a, b, and c gives you Tn. All right, 2.1.3 is a question that we often ask you in some form. So we often ask this question in some variation. And then, again, not hard questions, but there's something we often forget about quadratic sequences. Now, if you look at this pattern, we know it's quadratic because of the squared. What we need to understand is that graphically, that means we are working with a parabola, okay? So that means that we could draw, or we could represent this number pattern. I don't know what's happening. There's a lot that's about to happen. We can represent this number pattern as a parabola. Okay, it's not going to be an accurate parabola because we don't have a whole lot of information, but it's a sad parabola. It's going to look something like that. Not that it's a terrible parabola, but you get my drift, okay? And like I said, oftentimes we give you these types of questions whereby we are relying on you to remember that it is a parabola. So it says what value must be added to Tn, so to this whole negative n squared plus 24n minus 143, for the sequence to have only one value of n for which t of n equals 0. So let's understand what that means. All of my input values are n. So that x-axis is n, and my y values are tn. So t of n equals 0 is essentially saying y equals 0. And essentially what it's then saying to me is that we only want one n value. Now, if we consider, let's say, for example, this value over here, because of the symmetry of a parabola, there are two different n values. There are two different n values that give us the same y value. We now want a situation where it's one n, one tn, one x, one y. And the only place where that happens on a parabola is at its turning point. So at its turning point, we have a singular n value and a singular tn value. That's the only place where that's going to happen. And so essentially what I'm asking you is, how do we get this turning point down to be where y is equal to 0? Because that's what I want. How many units do I need to shift this parabola down so that its turning point is at 0? That would then require me to go and figure out where the turning point of this parabola is, because I first need to know where its maximum is in order to figure out where I'm shifting it. Okay, so we know to find the turning point. Obviously, you have first derivatives as well. You're more than welcome to find the first derivative, but we do just have this little formula that we can use, the minus b over 2a. If we substitute in those values for b and a, we've got negative 24 over 2 times negative 1, which gives us 12. So what we've worked out here is the x value or the n value. So we are saying where n equals 12, we get our turning point. Okay, so let's maybe draw a slightly more accurate parabola, whatever that word was that I was trying to say, parabola. So we have something like this. I now know that my turning point is where n is equal to 12. But I still need to go and figure out what this corresponding y value is, because that's going to tell me how much I need to shift it down so that I get to 0, to y equals 0. So I substitute this back into my equation. So t of 12 minus 12 squared plus 24 times 12 minus 143. Okay, minus 143. I'm not going to fight with it. And we get that the turning point would then be at 12, 1. So this y coordinate here is at 1, which means I need to shift this whole parabola 1 unit down so that it now sits on the x-axis where y is equal to 0. So I essentially need to subtract 1 or add negative 1 to this equation to shift it down enough so that my turning point sits on my x-axis. Okay, guys, this is like a nature of roots question, right? It's not a hard question. It's understanding what the question is asking you. Now, I understand within the context of sequences and series, our mind is not on parabolas, but you need to remember, because often we ask these types of questions, you need to remember that a quadratic number pattern is just an algebraic form. Oh my gosh. It's just the algebraic form of a parabola. Okay? It's just the algebraic rule of a parabolic function. Alrighty, so let's screenshot this. Again, I know that second... I can't speak today. I can't use my brain today. Anyways, I looked at a child today asking me a question and I heard absolutely nothing she said. I had to get her to repeat it because my brain's just... Anywho, so this 213, not a hard question, but it's going back to understanding that this is a parabola. And I think, guys, sometimes we forget how intertwined maths actually is and how much overlap there actually is between sections. Okay. So I hope we've got those screenshots. And guys, when you do get questions like this, if you're really in doubt, find the turning point. At the bare minimum, find your turning point, because that's probably going to get you some marks, especially even if you don't know really what you're doing. Just find the turning point. It'll probably get you something because it's probably asking you something about that. Obviously, I've forgotten the mark allocation. So method, finding your turning point, getting your value for n. So like I say, if that's all you can do, you've got 50% for this question, and that's good enough. Subbing back to figure out where that y value of your turning point is and figuring out that you need to move 1 unit down. Those are your 4 marks there. Dorato?
Ma'am, so I have 2 questions. My first one being, it's in correlation to 2.1.2. So ma'am, that first step of yours, like where you figured out the differences, I did that in 2.1.1 in pencil. Is it okay if I do that in like the exam room? Just as long as my final answer is in pen.
Yeah, that's fine. I actually usually do all of this up here right at the start of the question. So you can do it anywhere because the marks are allocated to the equations, not necessarily the working out.
Okay. And then my second question, ma'am. So it has to do with like, it's similar to 2.1.3. So ma'am, how would you approach the question if it had asked us between which two terms of the quadratic number pattern would there be a difference of like a certain number?
Okay, so this is now where we have to understand, and this is a good question. This is where we have to understand that the first differences of a quadratic pattern form a linear pattern. So we've got negative 120, negative 99, negative 80, negative 63, and then we have all of our first differences. 21, 19, 17. These first differences form an arithmetic pattern. Okay, so a linear pattern. So I could find a Tn for this. So Tn would be equal to minus 2n plus 23. Yeah, I'm not making that up. That is actually the formula. If you substitute in 1, negative 2 times 1, negative 2 plus 23, 21. Okay, you can't do it by inspection. However, that's not the point. So you can go and find your Tn formula. And what that means is if I'm saying to you where the difference is, let's say I'm asking you between which 2 terms is the difference 5. Okay, I'm then giving you your Tn value. So you can now substitute in 5 and you can solve for n. So this would be negative 28 equals negative 2n. So therefore n equals 14. So what that is telling you is that the 14th term of this linear number pattern will have a difference of, or will have a value of 5, which means the difference between the quadratics is 5. Now, what you have to remember is that term 1 of your linear is the difference between term 2 and term 1. Term 2 of your linear is your difference between term 3 and term 2. Term 3 of your linear is your difference between term 4 and term 3 of your quadratic. So if term 14 is what I'm looking for, it would be the difference between, I'm trying to figure out how I wanted to write this, difference between the 14th and 15th terms of the quadratic. Okay, I know my handwriting is absolutely shocking. I do apologize. You're just going to roll with it. So with that type of question, it's understanding that it forms a linear pattern, and then it's easy to go work out Tn and go from there. Does that answer your question, Rachel?
Yes, it does, ma'am. So, ma'am, in my prelim, I got a similar question. Does this mean there's a higher chance that in the final I might get a question that has to do with like the parabola instead of the, or is there like a 50-50 chance?
I would say probably 50-50. I can't remember what they got asked last year. I would go more, I would make predictions more based on final exams rather than prelim papers, just because, excuse me, prelim papers are based on provincial, geez Louise, could not think of the word there, are based on provincial situations, whereas the final paper is across the entire country. So last year, let's see. Last year, I'm pretty sure it was a quadratic question because I remember distinctly trying to figure it out. Yeah, so last year's question was to do with a parabola. The year before, probably I think it was also a parabola the year before. They like the parabola type question. I'm not saying they don't ask this different situation, but they do prefer a parabola question just because it does test nature of roots. So, oh no, I'm joking. So 2022, it was a question, but which two consecutive terms in the quadratic number pattern have a first difference of? So, I don't know. Like you say, 50-50, it's going to be one of them. I'm leaning towards this type of parabola question, but it could be either.
And then I wanted to ask, ma'am, for the question I asked, would it be a similar type of marks or would it be higher marks?
Similar type of marks. So you get a mark for getting your Tn, a mark for working out your n, and then a mark for the terms that it's in between. So 3 or 4 marks as well. Yeah.
Okay, thank you, ma'am.
Sure. All right, Go-Tels, I'm aware of the fact that it's past 7. I know we didn't do a lot of sequences in series, so I do encourage you to go and revise this independently and ask me questions. What I will try and do is at the end of Wednesday's lesson, try have some time, like 10-15 minutes, where you guys can just ask me questions. Because we're going to do stats and analytical, which really are quite easy sections, and I just need to hone and focus. And what I might actually do for the stats thing is not necessarily go through all of the stuff in the beginning, but just make you take screenshots of it and go, and we'll just get started. So please do go and revise number patterns independently so